Hello everyone, welcome to my channel Mechanical Zone. Sambit. In this video, we will discuss resolution of forces. So, first question arises in our mind by knowing the term resolution of forces. What is that resolution of? Resolution of forces is a simple process of splitting a single force to number of forces in which the number of forces will have the same effect as that of the single force. Is called as resolution of forces. Then, in simple, we can divide a single force into multiple number of forces, which is quite opposite to that of composition of forces, which we did in Strangel's law of force addition, parallelogram law of force addition, and polygon law of force addition. In those composition, what we did, we have added force, multiple number of forces, and we have converted into a single force. But here we'll do the opposite. We will divide a single force into multiple number of forces. But a general practice which we follow, in which we divide a single force into two mutually perpendicular components. Mutually perpendicular components generally in x-axis and y-axis, and they are termed as cos components and sine components. So let us take an example of resolution of force. This is our condition where this is the y-axis, this is the x-axis, to which a force F is acting at an angle theta to x-axis. So what do you do? To draw two perpendiculars, one to the x-axis, one perpendicular to the y-axis. One perpendicular to the y-axis. After that, you mark it as 0 or O, A, B, and C. So consider OAB triangle, OAB triangle, OAB triangle, which is a right angle triangle. Right angle triangle means one angle is 90 degrees. The right angle triangle. So one angle is 90 degree, and the this side, F side, is called as our hypotenuse of that angle. So OA equals to hypotenuse is equals to F. We are considering only magnitude of the forces. OB is the base as it is adjacent to the angle, and AB is the perpendicular. So let us consider this triangle. The cos theta will be base by hypotenuse, which is OB by OA. You can easily say that OB will be equals to OA cos theta is equals to F cos theta. Similarly, our sin theta is perpendicular by hypotenuse, that is AB by OA. So AB is equals to OA sin theta. So easily I can say F sin theta. And you know OCAB is a rectangle, and this side AB is equals to this side. As we are considering magnitude, we can easily divide the force F into two components as F cos theta along the x-axis or OB, F sin theta along the y-axis, that OC. So Let us do it. So we can easily say, if this is the y-axis, the x-axis, our force F is acting at an angle theta to the x-axis, then we can easily say that this component, our F can be divided into our F cos theta along the x-axis and F sin theta along the y-axis. So we can easily say that angle along the x-axis and along the y-axis. Why? We can take the consideration of parallelogram law of force addition, which is quite equivalent to this. So we can easily say that we can resolve a single force F into two mutually perpendicular components that are F cos theta and F sin theta. Or we can easily say this F with an angle theta is equivalent to this theta F. So always remember, this is the trick. When you are resolving the force into two components, the component which is connected to the angle is always the cos component and the other component is the sine component. Similarly, we can easily say this also. Let us do this. If the force F is acting at an angle theta to y-axis, then you can easily do the resolution of force like this. F cos theta along the y-axis, F sin theta along the x-axis. As I said, the angle which the side, the perpendicular component which is connected to the angle is always a cos component, and the perpendicular component which is not connected to the angle or the rest perpendicular component is the sine component. So if the system is like this, if the force is acting on the second quadrant, then angle theta to the negative x-axis. So your force resolution will be like this. You can easily do this as the fx component will be minus f cos theta, as it is connected to the angle and along the negative direction, that is my negative, and f sin theta as it is along the positive y-axis. No need to draw this. This is not required because we are converting a single force into two mutually perpendicular forces. Like that, you can easily do this also. Along the y-axis, this is the negative x-axis. Similarly, you can do for third quadrant also. This is theta. This is along the negative y-axis, x-axis. This is negative y-axis. Similarly, we can easily do anywhere or any if the force is acting on any quadrant, you can easily do. But always remember, in order to resolve a force, you need to keep in mind two things: the forces which we are resolving into, or the two components should be perpendicular, should be mutually perpendicular, and the component which is connected to your angle or which is adjacent to your angle, the cos component, and the component which is adjacent, not adjacent, or the rest component, the sine component. So hope after watching this video you can easily convert or resolve of the forces into two mutually perpendicular forces. So don't forget to like and share the video and to subscribe my channel. Thank you very much. Hope you enjoyed the session.